share. Now it is live stream. Follow me.
Yes, sir. Is the meeting started to record, sir? Is
Yes, meeting start.
okay, perfect. A very good afternoon to all of you, and welcome to the 7th Foundation Day of South Asian Meteorological Association. It has been like since 2020, 7 years that we have all joined to a okay, the recording has started now. So, welcome everyone to the 7th Foundation Day of the South Asian Meteorological Association. And it has been 7 years since 2020, where SAMA has hosted a lot of outreach, capacity building, and educational programs for advancing atmospheric science for climate resilience South Asia, joined by all our member countries. And today, uh, I'm Poulami Chakravarti, ECT member, and the digital platform manager of SAMA, joined together by Dr. Mohan Kumar Das, Joint Secretary SAMA, and Executive Director of Hydroclimate and Ocean Center from Bangladesh as the moderators of the session. And I would quickly like to invite upon our President AVM, retired Professor Ajit Tyagi sir, and Professor Someshwar Das sir, who's the SAMA secretary, to come on and start the session. First, I would like to request Tyagi sir to welcome the audience and start the Foundation Day
Thank you,
celebration.
Poulami, for moderating this important event. Also to Mohan, who is in Japan, extending his support to us. Very good afternoon. It's a matter of real great honor for me to extend warm welcome to Chief Guest, Dr. Krishnan, former Director of Indian Institute of Tropical Meteorology, Pune, and also an eminent climate scientist, worked closely with the World Climate Research Program of WMO, and present he is heading the Center for Research on Climate Sciences at IISTS, Bangalore. We have two eminent guests of honors, Dr. Amita Bandyopadhyay, who is DG of the Non-Aligned Movement SNT Center, and he is a science administrator bringing all non-aligned countries on a platform, and we are happy to work with him. We have come up with the fact file on the heat waves with the NMSNT, so his support has been of great strength to us. Also, we have a DG Nepal's Department of Hydrology and Meteorology, Dr. Archana Shrestha. Again, Nepal has been a great partner of SAMA's activities, and we have also started work on developing a country chapter in Nepal, so that is very heartening. Also, we have a moderator of the panel session, Dr. Kamaljeet Ray, scientist and advisor to the Ministry of Earth Sciences, Government of India. She has headed many programs related to nowcasting and climate services. Among the panelists, we have a wide range of specialists, eminent personalities participating, starting with Professor Sahaja Mondal from the BUET, Bangladesh, Dr. Pradeep Thapliyal from Space Application Center, Ahmedabad, Mohammad Irfan Tariq from Pakistan, ex-DG of Pakistan Met Department, and is a climate policy leader. Dr. T.N. Rao from NARL, and Dr. Namasu Chattopadhyay, who has been heading the SAFOM as a secretary and had played a key role in operationalizing aggregate services under Dr. Rathore and IMD. So really thankful to each one of you and all other eminent personalities who have spared their valuable time to attend this event of SAMA, which is of great interest and for us. Your support is immensely valuable. As far as SAMA is concerned, you all know that it was formed on 3rd August 2002 amidst the peak of COVID pandemic, where no physical meetings were taking place and permitted. And SAMA provided a virtual platform for meteorologists of the South Asia to interact and really implement the Weather Without Borders concept in practice. It was wholeheartedly supported, the initiative by the meteorologists from all 9 South Asian countries, both serving and the retired veterans, and that enabled us to move forward. The primary focus of SAMA has been on capacity building, outreach, and service related to awareness. Over a period of 6 years, SAMA has grown from strength to strength. Today, SAMA has 850 members, of which 500 are life members and 350 are student members. SAMA has carried out 150 activities in last 7 years, of which only 2 recent activities, that is a training workshop in radar meteorology and teachers training workshop, were funded by MOES. Rest all were carried out zero budget, and it was possible only by the volunteer support of all of you. So I'm personally grateful to each one of you who have enabled us to carry out wide-ranging capacity building activities, starting from the school children to the teachers, the graduates and postgraduates, through the online lecture series, which reached to 50 countries thanks to the name participation. And we had on an average 1,000 plus registration from the students. These used to be 2025 lecture series delivered by the eminent meteorologists and the experts, and had been a great success. In all, we did the 5 online lecture series covering atmospheric physics, atmospheric dynamics, satellite meteorology, radar meteorology, and also the numerical weather prediction, where hand-on practice also was given to. So this has been great success, and these efforts have been appreciated by the Secretary General of WMO, Professor Celeste Sauler. Now we are working on new initiatives, which involves the research project on the cloud bus issue, which is very, I think, even prominent now in the Himalayas. And along with the Nepal, we were working on a joint project or research project. Also, we have an initiative of where we encourage young researchers in the research colloquium, where the experts provide them guidance and mentorship is provided. So these are the new initiatives. Along with this, we also would like to do, there is a great demand of doing physical workshops now from the various users. So we are exploring the possibility that how we can do it. In fact, the idea is that we should be able to reach each one right up to in the remotest place of the country through both virtual and real-time interactions and outreach programs. And important part of this is going to be the focus on the weather hazards and the services which are being provided by the National Met Services, so that they can benefit, also take precautions against hazards. So these are the new initiatives which we would like to launch. All this, as I've told you, wouldn't have been possible without support of each one of you, especially the guidance provided by the Executive Council members and Advisory Committee members, and all volunteers who have delivered lectures or guided us in various activities wholeheartedly. I'm also thankful to the young dynamic executive coordination members, which you will see during that all these programs have been planned and conducted in-house by our student and the coordinators, and of course under the leadership of Comeshwar Das. It is a very cohesive team from all 9 countries that were their young coordinators plan and implement various activities planned by us. So thank you so much. We are moving from strength to strength, and there is a felt need that yes, we should do more work in the field through various capacity buildings and training programs. And for this, we look forward for your support guidance. Thank you.
Thank you, sir. Thank you for your magnificent and benevolent speech. It inspired all the SAMA members very nicely. Now I would like to request our Honorable Secretary, Professor Dr. Someshwar Darsar, to deliver the brief activities of the SAMA. Sir, floor is yours.
Okay, thank you very much, Dr. Mohan. I hope I am audible. Let me share my screen. Can you unshare your screen, Dr. Mohan? Okay. share your screen.
Yes, sir, it is coming, sir.
Can say that.
Just a minute.
Sir, your desktop is showing. Yeah, yes, sir. Okay. The presentation mode, sir, please.
Okay. Good
Now
afternoon.
perfect. Now perfect.
Is it okay?
Yes, sir. Fine.
So I hope I'm audible clearly. As you know, we are celebrating today the 7th Foundation Day of SAMA. At the outset, I would like to, in fact, thank our chief guest, Dr. Krishnan, for kindly agreeing to be the chief guest at a very short notice. Just for yesterday, I requested him, and he very kindly agreed to be the chief guest. So thank you, Dr. Krishnan, very much for that. Also, Dr. Tyagi Saab has already briefed you about the activities of SAMA, but let me tell you slightly more in detail.
Actually, in message box, people are also saying that sound is not coming properly. So
Not yet. Still
your
not
sound
audible,
is
yeah.
coming properly.
Let me try some other method if I can do that. Let me just 1 minute. Let me just try. Some problem with the sound.
I say that you stop that Bluetooth one and talk directly from the laptop. It may work better.
Remove the Bluetooth. System. Just a minute here.
Swagataji, I think Dr. Dars's sound is quite okay. You can hear?
I mean, some people are
I
able to
have
hear.
got
Some
in the
people
chat box. You can see.
Yeah. But I think now it is quite better.
better.
Okay, sir. Okay, sir.
I
You
think
continue.
it is all right.
Can I
Okay,
continue?
okay, sir. Continue. Sir, continue.
Okay, thank you so much. This is always a hitch in the online presentation. Okay, so let me quickly brief you about the activities of SAMA, especially since the last 1 year, since the last Foundation Day, and this will be, I know, a repetition for many of you, but also for many of you, it will be for the first time who are attending this program of SAMA. First of all, as of today, SAMA has total 863 members, out of which 508 are life members and about 355 are student members. And country-wise backup is given here. In the bracket, what you see is the increment since the last Foundation Day. That means on 3rd August 2025. What is the increment? So from Afghanistan, we had 21 members, which is 1 member increment from the last year. Bangladesh has now 87 members, which is 13 increments since the last year. Bhutan has got 13 members, and there is a 0 increment from Bhutan in the last 1 year. India has got 199 members, 13 members increment from the last year. Maldives had got 8 members, 0 increments since last year. Myanmar has 25 members, 0 increments since last year. Nepal has got 59 members, life members, of course, 12 increments since last year. Pakistan has got 55 members, 0 increments since last year. Sri Lanka has 35 members and 1 increment since last year. We also allow international members outside South Asia, and so far we have got 6 international members also, 0 increments since the last year. On the right side, what you see is the student members from each country. Afghanistan, we have got 2 student members. Bangladesh has got 201 student members, which is the highest among all the South Asian countries. Bhutan has got 0 student members. India has got 79 student members. Maldives and Myanmar have 0 each. Nepal has got 52 student members. Pakistan, 14 student members. Sri Lanka, 4 student members. And we have got 2 international student members. Well, SAMA has got 7 scientific committees, including education and outreach, numerical weather prediction, satellite meteorology, radar meteorology, air pollution, climate change, and mountain meteorology. We have got about 16 knowledge partners, including EC Mode. Most of you know what is EC Mode. That is International Center for Integrated Mountain Development, located in Kathmandu. rhymes, everybody is familiar, I hope, located in Thailand. Of course, the NAM SNT Center, the Northern Women's Center for Science and Technology. And we are very proud to have NAM SNT Center as our knowledge partners because due to its Director General, Dr. Bandyopadhyay, we got very good response to our lecture series because the NAM SNT Center is our knowledge partner. So therefore, all the activities of SAMA, including lecture series, are also open to the member countries of NAM. And they've got about 47 member countries. So because of that, the response to our lecture series were enormous. Like we got about 2,000 registrations for our different lecture series from about almost like 50 plus countries for different lecture series that we conducted. I shall tell you about that shortly. Then we have got knowledge partner SASINE, that is South and Southeast Asia Network for Environmental Education. SAFOM, as you know, is sister organization of SAMA, that is South Asian Forum of Agricultural Meteorology. Charlotte is the South Asian Lightning Network. SAHIN is the South Asian Heat and Health Information Network. SRMIST is a university in Chennai. CSAC, as most of you know, is Center for Development of Advanced Computing in India. BIT Mesra, almost all of you know, this is the Birla Institute of Technology. Then we have got ACAR, that is the Advanced Center for Atmospheric Radar Research at Cochin University of Science and Technology, which is very actively supporting us in conducting our joint programs. Like recently we conducted a training program come workshop on radar meteorology in the last April. Then we have got knowledge partners of Department of Meteorology, Dhaka University, Bangladesh. Then we have got CDHM, Central Department of Hydrology and Meteorology at Tribhuvan University, Kathmandu, Nepal. We have got SP Pune University, the Savitri Bai Pune University. They are also helping us a lot. They conducted jointly with us a 5-month, 6-month lecture series on dynamic meteorology. NOAMI, Bangladesh, and FERCC, the Foundation for Education Research and Climate Change. So these are our knowledge partners. The major activities that we conducted since its establishment is about 141. Whereas since the last Foundation Day, we conducted about 32 activities in the last 1 year. All activities except the last two, as Dr. mentioned earlier, the last two, that means the one which we conducted training workshop at on radar meteorology at Cochin University, and the second one, the WISE training program at Pune University. Those two activities were funded by the Ministry of Earth Sciences, whereas the rest of the 139 activities were conducted by SAMA without any external funding support. We conduct webinars, training workshops, capacity building programs, lecture series. So far, as Dagisa mentioned earlier, we conducted a lecture series on atmospheric physics for 4 months, in which 2,000 people registered from about 48 countries. We conducted training program on WRF modeling system for 3 weeks. Then we conducted a lecture series on satellite meteorology for 5 months, in which 1,800 people registered from 59 countries. We conducted training lecture series on radar meteorology for about 6 months, in which about 1,200 people registered from about 48 countries. We conducted most recently the last lecture series on atmospheric dynamics, which was for 5.5 months, jointly with Pune University, in which 1,145 people registered from about 51 countries. We also conduct special day celebrations like the WMO Day, the Ozone Day, quiz contest for school children, and I always repeat, and for those who are returning for the first time, in our quiz contest, about 22,000 school children participated from the Southeastern countries, and it was a big achievement, I should say, for SAMA in the very beginning of its establishment. We also conduct special lecture series on the works of the Nobel laureates. As you know, 2 years ago, Nobel Prize was given in the field of atmospheric and climate sciences to 2 professors. One was Professor Manabe, Sukuro Manabe, and the second one was Professor Hasselman. So what led them to win the Nobel Prize in this field was discussed in our special lectures on the works of the Nobel laureates. Then recently we have launched about 4 programs One is the radar meteorology, frontiers in observation and prediction. As already mentioned, we conducted in the last April a training come workshop on radar meteorology jointly with the ACAR, that is the Advanced Center for Atmospheric Radar Research at Cochin University of Science and Technology. Thanks to Professor Abhilas, the director of that center. Then we conducted a teachers training program called WISE, Weather, Climate and Environment in School Education, jointly with the Pune University in the last April. Thanks to Professor Rohini for coordinating the program. Then we have got a third program launched recently called In Clouds, that is the cloud-based research over the Himalayas, and that's going on quite well. We recently wrote a review article on that jointly with about 34 co-authors who are our members of this team. And this review paper is almost going to be published in the reviews of geophysics shortly. It is in the process. Then we have got also a program called YORS program, that is Young Researchers Colloquium, which was launched last year on the same day, on the Foundation Day of SAMA last year. We launched this program, and this program is for those students from the South Asian countries which are less privileged and who get less opportunities to interact with international scientists, experts, who get less opportunity to present their papers outside in the international conference. So we give them this opportunity to present their PhD research work, their ongoing PhD research work, as well as the MTech thesis research work. We give them opportunity to present in the YORS program, and we have also kept some award for the best presenters, thanks to our knowledge partner FERCC, Foundation for the Educational Research in Climate Change, Professor S.K. Das and Professor Bhaskar Rao sir, who are the founding members of this FERCC, who have sponsored this YORS program. Then this map shows the global distribution of the participants who registered for our lecture series. I can see, most of the South Asia as well as even abroad. USA and Africa and Australia, people registered from those countries for our lecture series. As I mentioned, we launched last year the YORS program called Young Researchers Colloquium, and PRCC has established the awards for the best paper. We give total about 15,000 rupees cash prize plus citation certificates to the first three winners. And the convener of this program is Professor T.V. Lakshmi Kumar, Associate Professor at Jawaharlal Nehru University, New Delhi. Then, as I mentioned, we launched the second initiative on the RAD map, which is the radar meteorology frontiers in observation and prediction. And we conducted the training workshop jointly with Cochin University of Science and Technology last March. Then yours I have already mentioned, I think, so I will just skip. Oops. Okay. Then WISE SAMA, of course, the weather, environment and climate in school education. As I mentioned, the first training program on the teachers training program on WISE was conducted jointly with Pune University in last April 20 to 25, 5 days. And the fourth program is the In Clouds program for the cloud-based research over the Himalayas. So these are our recent initiatives. We also published 6 monthly newsletters, and last newsletter was published covering July to December. We are now awaiting inputs for the current newsletter covering January to June this year. Also, shortly we shall be launching officially the second brochure of SAMA. It will be launched shortly after this. Then, as most of you know, SAMA also has instituted a Students Champion Award, the SAMA Student Champion Award, for those students who help SAMA in coordinating its activity in helping different programs. So every year we give the best student awards and call it as SAMA Student Champions. And this year also 4 students were selected, which will be declared shortly. Results will be declared shortly for these SAMA Student Champions of 2026. Then SAMA is present on different social media, like it has got a website, has got a Twitter handler. It is also present on the Facebook. It has got an account on Facebook. SAMA has a YouTube channel. This current program is being live streamed on the YouTube channel of SAMA. All the videos of the webinars as well as lecture series that we have conducted so far are available on the YouTube channel of SAMA for anybody to view. We have got a WhatsApp group, very active WhatsApp group, and also a Google group of the emails of all members. We have also got LinkedIn, and recently we also got account on the Instagram. So regarding the highlights of the future programs of SAMA, of course, as I mentioned, a WISE program, that is the teachers training program that we conducted, the first program at Pune, that has to be replicated all over India, and also in all the member countries in course of time, we hope. So this has to be continued annually. RADMAP, the radar meteorology training program, also is a annual program. The first program we conducted this year, but subsequently next year onwards also we shall be conducting this program jointly with Cochin University of Science and Technology, hopefully, and any other university who come forward to host this program jointly with us. Similarly, in-cloud program is also a long-term program for about 4 to 5 years. Hopefully, depending upon the funding support that we receive for this program, this will be continued. Then exploring funding resources for conducting regional programs, of course, and as I mentioned, thanks, I've also mentioned, recently, for the first time, the Ministry of Science and Technology has sponsored 2 of our programs to conduct physical training. And hopefully more funding support will come so that in future we shall have more physical programs. And we are really hoping and dreaming that in course of time, when we have enough fund, then we should be able to establish a physical office with a physical staff to help us, because there are lots and lots of activities of SAMA nowadays, and it's becoming beyond our kind of limit to handle all those programs, because all our volunteer members and faculty members who are supporting us, basically they are full-time researchers or faculties in different universities. So whatever help they are doing us, is basically going out of their time limit, out of their office hours to help us. So we need badly office and research staff, for which we need fund, and hopefully in future we shall have that. Encouraging the member countries to establish country-wide chapters. Of course, this is one of the program as mentioned in the Constitution of SAMA. Recently, of course, we have been talking about this. In principle, we have 2 country chapters, one in Nepal and one in Bangladesh, but still it has to be formalized properly. And I hope in course of time, other countries will also have its own chapter. There are lots of advantages of having country chapters, which we have mentioned numerous times during the general body meeting of SAMA. I'm not going to elaborate those things here. Then develop capacity building programs, lecture series. We have already conducted 5 lecture series, but more we have to conduct, like on urban meteorology, data assimilation, air pollution, climate change, artificial intelligence. The most recent we talked about algorithm of computer machine learning for research and development of this region, especially for its application within climate forecasting. Conducting need-based training workshops for the member countries to improve their meteorological and hydrological services. Explore the possibility of partnership with more regional agencies in addition to ICMO, RIMES, NAMES, Center, etc. Develop linkage of SAMA with other international agencies in the field, such as IFMS. IFMS is the International Federation of the Meteorological Society. I hope Dr. Alvalia is here. I have given him a mail. EMS is the European Meteorological Society, and WMO, everybody knows. Develop regional research projects, of course, mentorships to young researchers and students by senior scientists. Work with the NMHMS, the National Meteorological and Hydrological Services, regional associations and civil society in promoting application of meteorology for public safety and societal benefit, social application on climate change, agriculture, aviation, energy sector, etc. Energy private sector in promoting application of new technology in instrumentation and software meteorology. So these are highlights of the upcoming programs. So thank you very much for your questions and for patiently listening to me. Thank you very much. On to you, Dr. Follow.
Thank you so much, Professor Someshwar sir. Now I kindly request Professor Millie Ghosh, who is an associate professor of remote sensing at the Birsa Institute of Technology, Mesra, Jharkhand, India, to kindly introduce our chief guest of the session, that is Dr. R. Krishnan. I'll just share my slides quickly. Give me a moment.
Yeah.
I hope it's visible to everyone.
Yeah.
Okay.
Yes. Thank you, Dr. Polami, and good afternoon all. And it's my pleasure to introduce Dr. Raghavan Krishnan sir, who is a renowned climate scientist and a former director, Indian Institute of Tropical Meteorology, Pune, and presently heading the Center for Research on Climate Sciences, IISS, Bangalore. Next slide, please. Dr. Krishnan led CCCR IITM Pune in pioneering India's first Earth system model, IITM ESM, contributing directly to the global CMIP 6 and IPCC AR6 climate assessments. He coordinated lead author for IPCC AR6 WG1 report for water cycle and drafting author for IPCC summary for policymakers. He is served as the member of World Climate Research Program, WCRP Joint Scientific Research Committee of WMO and co-author of Hindu Kush Himalaya Assessment ICI mod. He also led the Ministry of Earth Sciences landmark first national assessment on climate change over the Indian region for the year 2020. He has more than 38 years of experience on advanced numerical climate modeling, monsoon dynamics, water cycle science across NCM, WRF, IITM, and IIHS. There are several awards and honors on his credit. Few of them are he is recipient of Ministry of Earth Science National Award for Excellence in Atmospheric Science for the year 2021. He is elected fellow of Indian Academy of Science, Indian National Science Academy, Indian Meteorological Society, and many more. We welcome you, sir. Thanks.
I will now share sir's
Thank you very much. Dr.
presentation as well. Give me a moment.
Yeah. Yes. Yeah. If you can share. Yeah.
Yes. Just a second.
Yeah. So let me begin. First of all, I would like to thank SAMA, President Dr. Tyagi Saab and Secretary Dr. Someshwar Das for this kind invitation. So it's really a privilege and honor for me to be the chief guest for the 7th Foundation Day celebration of SAMA. And so the title is Advancing Atmospheric Science for Climate Resilient South Asia. So when Dr. Das called me 2 days back, I was thinking what I can talk. Can we go to the next slide, please? So I thought I'll focus on this year's monsoon and some of the climate projections that we are having. So we can see already in the last 3 years, the mean temperature was almost 1.5 degrees, and 2025 was the third warmest year on record. Of course, I don't see the picture of the carbon dioxide concentration on the screen. Because the concentration, the GHGs have increased, and in the CO2 concentration in 2024 was close to 424 parts per million, and that corresponds to about 3,300 gigatons of carbon dioxide in the atmosphere. So climate change is already happening. Next slide, please. And the temperature changes are not uniform. Much of the warming you can see in the high latitudes. Tropics are also warming, but the magnitudes are much smaller. Next slide, please. This is from the WMO State of the Global Climate Report. And this is the, next, previous slide. Previous. Yeah. Oh, next one. I don't see this picture. Yeah, this is the annual precipitation 2025 expressed as percentiles. I'm not able to see the picture. I don't know why. Yeah.
I'm also not seeing it on the screen. So can I just stop sharing a second and see if it is visible?
Okay.
Give me a moment. It doesn't show on the screens on the presentation for some reason.
Okay.
I'm sorry, let me reshare again, but I believe it
Okay.
doesn't show.
Okay, no problem. What we'll keep moving on. Maybe some technical glitch. Yeah. So many places we see extremes in the precipitation, and one of the consequences of this warming is the water vapor feedback because of the saturation vapor pressures dependence on temperature, and due to this, for every 1 degree warming, water vapor increases in the atmosphere by 6 to 10%. That's something like 7% approximately on an average. And if you see the observed increase in the frequency of heavy precipitation globally, that is also something like 7% per degree warming, similar to the water vapor increase. So next slide, please. And I had put circles, again, this is from the WMO Global Climate 2025, State of the Global Climate. All these circles are the extreme weather flood events, heavy rainfall and flooding events in different parts of the world in 2025. Next slide. Unfortunate. So now the question we are asking is, how does this global warming, how this climate change is affecting the Indian monsoon? And basically, it's a Indian monsoon is a very complex dynamical system. We have the mighty Himalayas and the Tibetan Plateau to the north, which are basically preventing the intrusion of the cold and dry air, extratropical air, yeah, uh, into the Indian landmass, into the Indian region. And and in the south, we have the mighty Indian Ocean, which is an important source of moisture. And the monsoonal winds interact with the cross-equatorial winds. They interact with the Ethiopian mountains here, East African mountains, and they are very important for concentrating the what is known as the low-level jet or the Somali jet, which so that the moisture-laden winds interacts with the Western Ghat mountains and the Burmese mountains, and leading to the formation of cumulus clouds, organized clouds, which is a very important ingredient of the monsoon. So the latent heat released by cumulus clouds uh, is substantial, and now we have that information from the satellite data, and which can in turn strengthen the monsoon as a feedback. So now the question, next slide, please. And when we look at the long-term climatology and the year-to-year variability of the Indian summer monsoon, it is affected by a number of drivers, like the ocean atmosphere coupled interactions associated with the El Nino Southern Oscillation, as well as the Indian Ocean Dipole. And in fact, these two drivers have been listed in this year's WMO report. And external forcings like greenhouse gases and aerosols, which kind of counteract the greenhouse gas warming, land use, land cover changes, and atmospheric internal dynamics. But when you go to very long timescales like paleoclimatic timescales, even changes in the Sun-Earth orbital parameters can affect the monsoon on a variety of timescales. So the key thing is what I want to say. This is again from the IMD IITM data set. We can see many of these drought deficit years in the past have coincided with El Nino, but not all of them. And many of the wet years are have been accompanied by La Nina events. But there have been exceptions like 1997, despite being a very strong El Nino, the Indian monsoon was normal. And that year we also had an IOD, Indian Ocean Dipole, which was discovered later. Likewise, the 1994 and the 2019, very big, very strong monsoon events, they were all accompanied by positive IOD event in the Indian Ocean. Next slide, please. So this year, one of the news that has been that there is going to be a big El Nino. They are telling it could be a super El Nino. And this is what would be, this was happening before the monsoon season. So it may be a lot of news going in the media that this year monsoon will be very severely affected and so on. Now, this is the latest sea surface temperature anomaly map from NOAA. Of course, we do see significant warming, more than 1.5 degree in the central and mostly in the eastern Pacific. And another interesting feature we are also seeing in the latest is the development of cold sea surface temperature anomalies off the coast of Sumatra. And I think the southeasterly trade winds are picking up. So there is more upwelling in this region. So the cold waters from below are coming up, and we see the development of an IOD. So the latest news I see is that there could be a positive news because of the IOD. It could counteract the Indian monsoon, and we may not end up in a big deficit this year. But anyway, there are two more months to go. Let us see. Next slide, please. Oh, don't know why this is also not showing. Anyway, this picture was showing the evolution of the Nino index, the relative ocean Nino index, showing the emergence of the recent El Nino. Next slide, please.
Can I just see if it works better on this is on Google Slides, if it works better on the PPT itself? Just
Yeah, you can download. Yeah, you can download. Then please share.
yes, sir. Just a moment. Sorry for all this trouble.
Download and share probably.
Yes, it
I
is working.
did that, but the thing that I downloaded also doesn't show actually. Let me again.
Then I can share.
Okay, sir.
Okay, Deepak.
Okay.
So, shall I send it to you, sir?
I have downloaded.
Okay.
Yeah.
It is 03 August. Now give me ready host.
Now it's yeah, I think we were here in this picture. This is the latest I took from IMD, downloaded from IMD. Of course, many of you are aware of this, so it's a kind of repetition. So the 2026 All India rainfall, to begin with, in the early June and mid-June, it was deficit. But end of June and early July, there was a kind of spell that was quite active. And again it went down, and in the later part, and from the mid-July onwards, we see again the recovery and strengthening of the monsoon rainfall, mostly over central India and also the western parts of India. Many places witnessed very heavy rainfall and flooding, including Pune and many places in Gujarat. And the rainfall deficit, which was very close to almost 40%, less than 40% in around mid-June. Now the latest is it has recovered almost, it has come to minus 11.5%. And so that's what we have to really wait and watch. And this is the image from the INSAT 3DS. We can see this very organized clouding over central India. And this was during 6 July, around this period when the monsoon was very active. And this is the second one on this 22nd July. This received massive rainfall and flooding in various parts of Gujarat and Maharashtra and other regions. So the monsoon, despite there's a lot of discussion going on, despite having an El Nino, why are we seeing this very interesting behavior of the monsoon? Next slide, please. Next slide.
Yes.
Yeah, in fact, yeah, I can see this. I can thank you. So, in fact, this was one of the earlier studies that talked about the most severe rainstorm of India. This was by Owen Dar and team. So, this talked about a rainstorm that formed in the basically the low pressure system that developed in the Bay of Bengal and went westward. And this led to massive rainfall. This was in 1941. And this is the track of the system. And this led to very, very heavy rainfall and flooding in various parts. This is the Dharampur, which received almost more than 1 day rainfall, was more than 50 centimeters of rain. So these rainstorms are getting really stronger, and which is what we are seeing this year as well. Next slide, please. And so one is the low pressure system. There is also the formation of this year. People are telling that there is a kind of metropospheric cyclones, which are usually they're kind of quasi-stationary. They form over the west coast of around the Gujarat and Saurashtra region and even parts of Maharashtra. And they can produce, and mostly the circulation, this was discovered by Miller and Keshwamurthy during the International Indian Ocean Expedition. And the circulation is mostly concentrated in the metropospheric levels, and they have a horizontal scale of 1,000 kilometers. And there is mid-level convergence and strong vertical velocities. Basically, the rainfall, for example, this is during 2006, which was also an IOD year. I will come to that. This is from the meteor satellite. So you can see very large-scale organization of the convection. And within this organized convection, these very deep embedded cloud systems are seen. And that can lead to enormous rain. So 3-day accumulations can be something like 700, 800 millimeters. And so next slide, please. So something that we are seeing this year as well. Next slide, please.
Yeah.
And also 1994 was one such event where the monsoon rainfall was very significantly above normal, all India. And much of the rainfall anomaly was over central India and extended all the way into Southeast Asia. And this was a period where there was a positive Indian Ocean dipole event. 1994. The earlier one was 1961 and then 2019. And so this is something probably we can expect this year also. Off the coast of Sumatra, there is a cooling, and usually the rainfall reduces in this place. And there is outflow. There is a high pressure sitting. There is outflow of this moisture, and which can be transported through the cross equatorial flow towards the monsoon trough. And there can be plenty of rainfall just to the south of the monsoon trough. Yeah, next slide, please. And so we also looked at the rainstorms in one of our recent studies over Western India based on the IMD data and several other precipitation data. So what we are finding is both the frequency of these events and also the duration is getting longer. So both are getting, there's an increasing trend. This is statistically significant, both in the frequency and the duration of the rainstorms. Next slide, please. This is exclusively focused over Western India. And so when we look at the circulation, the water vapor, and also the circulation pattern and the sea surface temperature for all these rainstorm event, it turns out this IOD-like pattern in the sea surface temperature emerges, and you have a strong transport of winds, cross equatorial flow, and increased water vapor content that delivers a lot of rainfall in this region. Next slide, please. So the question we are asking is, if the global warming is going to continue, what will happen to the Indian summer monsoon? Not just the precipitation, as well as the circulation. Next slide. So this is so general, even up to the AR5 and AR6 assessment, is that the land warms. This is the understanding that as the land continues to warm, land will warm faster than the ocean. And so there is going to be more, of course, there is going to be evaporation, there is going to be transport of moisture, and rainfall will increase. But the circulation will actually weaken. I will come to that, the physics, why they were explaining that the monsoon circulation will weaken, but there will be a slight increase in the precipitation. Next slide, please. This was the kind of narrative. And the physics behind the weakening circulation but more precipitation is as follows. So typically when you see precipitation is a kind of product of the vertical velocity and humidity, water vapor. Now when you look at the changes in the on the present and future, changes in the precipitation and the water vapor and the vertical velocities at the metropospheric level. So most of these models, the water vapor increase is like the Clausius-Clapeyron scaling, 7% per degree warming, but precipitation increase in the models is much less. It is sub-Clausius-Clapeyron, something like 1%, 2% per degree Kelvin. The result is that the vertical velocities will actually weaken, and hence the circulation will weaken. So this is the kind of narrative that has been going on, that the tropical circulation will weaken despite increase in the water vapor and despite increase in the temperature, because the precipitation increase will be very, very slight. Next slide, please. But do we see that in the observations? Now, when you see when you look at the GPCP observation rainfall data set and the winds from the era for 2 periods, this is a work of my student Ashwin. For the period 2003 to 2025 minus the previous period 1979 to 2002, there has been a recovery in the monsoon. So monsoon rains, by and large, they have increased. Of course, there are pockets where there is less rainfall, like the southern part of the Western Ghats and Northeast India. So the northwestern part of India and also parts of east coast of India, rainfall has increased. But interestingly, the cross-equatorial flow has also strengthened. So when the monsoon precipitation off the equator is increasing, we also see the circulation, the cross-equatorial flow has actually strengthened, so what the models are projecting, that in the future the circulation will weaken, is kind of counterintuitive. So next slide, please. So how to address this problem? So we went back to the original papers of which were looking at the monsoon as a moist model of the monsoon. They argued that basically models are having problems in the treatment of the deep convection, the tropical convection, the cumulus clouds. So this was a paper, this was a Nature News and Views on a paper by Boos and Kwang, where they highlighted that it is actually the Himalayas that are very important in preventing in blocking the cold and dry extratropical air coming into over the Indian landmass. So basically over the Indian land region, you have a lot of convective activity, and so the subcloud entropy is very, very maximum, very high in this region. And because of the convection and convective activity of the clouds, the upper troposphere gets warmed. And they use the theory known as the convective quasi-equilibrium framework, where they describe that the large-scale monsoon circulation and the cumulus convection scale are in equilibrium. And so for this, basically, they consider a model where the Himalayas have to block the cold and dry air coming into this Indian region, and the entire moist processes are concentrated. The deep convection and the moist processes are concentrated to the south of the Himalayas, and basically, which means that depending on the strength of the convection, that is what dictates the strength of the monsoon circulation. So once you have a very strong convection, moist convection over the Indian subcontinent, the monsoon circulation should intensify. And that is their argument. Next slide, please. The other component, so the Himalayan orography is important. The other thing is the Ethiopian mountains of the east coast of Africa. They are very important for concentrating the low-level Somali jet. And many studies, this was a paper by Brian Hoskins and Rodwell, where they showed that if you remove the East African mountains, the Somali jet becomes very, very weak. So these two orographic features, one is the Himalayas are very important for blocking the cold and dry air entering into the Indian region, and then the East African mountains channelizing the low-level Somali jet. And so this is what delivers the moisture-laden winds towards the Indian region, and then the moist convection develops. And next slide, please. Next slide, please. Yeah. So, okay, this is fine. So what we did was we used a global model, which is having a high resolution zooming over South Asia. And also this is where the grid size becomes less than 35 kilometers, so that we can reasonably represent the topography of the Himalayan region, where there are very sharp gradients, as well as the Ethiopian mountains. And when you go away from this region, the resolution gets coarser. And we have done various experiments with this model. This model has a very good simulation of both the rainfall and the low-level winds. Next slide, please. I'm not getting into the details. So we did 3 experiments, one for the historical period. That is basically we have taken a 20-year period from 1995 to 2014, and 2 future scenarios, CMIP scenarios known as the Shared Socioeconomic Pathway 245. That's a kind of middle of the road, medium emission scenario. And the other one is a SSP 245 with only greenhouse gas forcing. These 2 experiments are for the far future, that is 2081 to 2100. And this is the change in the sea surface temperature in the far future minus the historical from the coupled model. So basically we use this sea surface temperatures from the coupled model, the IPSL coupled model, and we have made experiments with this global atmospheric model with zooming over South Asia by prescribing the SSTs. Next slide, please. And interestingly, this model has a reasonably good representation of the low-level cross-equatorial flow. The rainfall over Western Ghats is very nicely captured by this model, although there are some differences in the precipitation over the bay. And the cross-equatorial flow is very good. Even the upper-level circulation, like the tropical easterly jet and the Tibetan anticyclone, are well captured in this model. Next slide. So it's a good model. So this is the key point. So what we found was, when we look at the difference between the SSP 245, 2081, 2100 minus the historical period, the low level 850 millibar winds and precipitation, we see, of course, rainfall. All these green colors means there is an increase in the rainfall. Interestingly, the winds are also strengthening. And it is more so if you had only the greenhouse gas forcing, the SSP 245, even there is a greater increase in the rainfall and a very, very strong strengthening of the low-level jet. So this paper is under revision. Next slide, please. So why is this happening? This is very different compared to all other CMIP models. We also find that the monsoon trough, which is a very extended trough that we see, the sea level pressure patterns, there is a very strong deepening of the trough, and even the deepening of the low-level pressure even further westward over the Pakistan and Saudi Arabia region. And next slide, please, in the future warming. So what we found was, we looked at the total heating, because as I was mentioning, due to the formation of the clouds and the release of latent heat of condensation, there's enormous heating of the middle and upper troposphere, and which we estimated by this apparent heat source in the model. And we see that in the future scenarios, there is a very deep heating, vertical heating in the middle and upper troposphere. There is a positive gradient, which is what really strengthens the mid-tropospheric circulation. Next slide, please. And yeah, can you, it's not very clear. Can you, excuse me, this slide is not very clear. No, can you go back to the previous? Now it's better. Yeah. So what we found was, we made an analysis of different variables: precipitation, vertical velocity, water vapor, and some strength of the Somali jet, and also a southerly shear index. What we found in this high resolution model was, the precipitation increase is not 1 or 2 degree per degree Kelvin. So our precipitation increase is far more than 7% per degree Kelvin. So the precipitation amount is much, much larger. So, and the vertical velocities are much stronger. Okay, they don't decrease unlike the CMIP models. So our increase in the convection and the vertical and the precipitation exceeds the Clausius-Clapeyron scaling. However, the precipitable water, whatever the water vapor is there, that is efficiently getting rained out as precipitation. our increase in the water vapor is much less, but whereas the precipitation is much higher, so the convection is getting stronger, and the circulation, the monsoon winds also intensify. So next slide, please. So once the winds are getting stronger, and we also see that the meridional shear increases in the Bay of Bengal, the many low pressure systems, the activity of the low pressure systems in the Bay of Bengal and even parts of India, the low pressure activity, and in fact the inland low pressure systems, that those tracks, they get the frequency increases, also the intensity. Next slide, please. These are the tracks for the 3 experiments. And this is the kind of JJ's track density of monsoon LPS for the historical SSP245 and SSP245 GHG. So clearly the activity of the monsoon LPS substantially increases. So the organization of the convection is intensifying with warming. That's what we are finding. And we are also seeing now, for example, in this year's monsoon. Next slide, please. And so that in the previous slide, I had a box covering North and Central India. So we looked at the precipitation exceeding the 99th percentile. For the historical is this black line, and these are the future, the SSP245 and SSP245 GAG. Clearly, you can see the tail of the extreme value distributions are not longer and also flatter. So the extreme precipitation is going to become more, they're going to increase. That's one of the biggest issues. Next slide, please. And they are mostly associated with these low pressure systems. So on the one hand, you have this issue of the organization of the convection and development of more low pressure systems and stronger low pressure systems which produce heavy precipitation. And definitely there is a need to strengthen our early warning system. Our IMD is doing a good job, but also some of these events really take us by surprise. We need to really strengthen those capabilities. But there's also an opportunity, because once we say that the winds are going to strengthen the low level flow, there is also an opportunity for wind power potential over India. And this was a paper from NRSC that talked about the wind power potential over India using the ERA5 reanalysis. What they have shown is the map of the exclusive economic zone, where there is a huge untapped potential for the offshore wind energy. And if indeed these are based on the winds at 100 meters above the surface, and so if we can, and of course Gujarat state and also the states of Puducherry, Rajasthan, Karnataka, Andhra Pradesh, Telangana, they are very good for wind resources. Now, if we can really cash on this wind energy potential offshore, that's a big opportunity. So next slide, please. Yeah. So can this make it a little clear? I want to just conclude. Can you,
Deepak, go back and go forward.
Yeah. Next slide. Oh, no. Previous slide, please. Oh, no. Slide 36. Yeah. So what I want to really say is already human-induced climate change is affecting the weather and climate patterns in every region. And the Indian monsoon is a very complex system, and there are multiple scales that are involved. And these are interactions involving the land, ocean, atmosphere, cryosphere. So it's really a challenging issue. And so when we look at we did a study to understand the effect of the global warming using this model, which has a zooming over South Asia, so that we can resolve both the Himalayan topography and because and also the East African mountains, because the gradients of the subcloud entropy, that is typically the cloud base, that's where the entropy is very high, and that is determined by the topography. So once you resolve the gradients of the topography or moist convection, you can do well. And what we find is in the future, it's not only the precipitation increases, also the convection and the strength of the monsoon, which exceed the Clausius-Clapeyron scaling of 7% per degree warming. And once you have increased subcloud entropy in a warmer and moister environment, it really creates a background for more organized convection, substantially heavier monsoon precipitation, increased genesis of the low pressure systems, enhanced latent heat release with deep vertical extent. And also we see a very strong positive cyclonic vorticity in the mid-troposphere and intensified cross-equatorial circulation. It's our plan to couple this model with the ocean model in the future so we can see what is happening to the interaction between the Indian Ocean circulation and monsoon. So with this few words, I want to end my talk, and thank you once again, Sama, and all the distinguished participants for this opportunity. Thank you very much. Jai Hind.
Thank you, sir. Thank you so much. Thank you.
Thank you, sir.
It's an amazing presentation. Everyone enjoyed a lot. Again, thank you, Dr. Raghavan Krishnan, sir, former director of
Thank you, Dr.
Indian
Mohan.
Institute of Tropical,
Thank you, sir.
Tropical Meteorology.
Thank you very much. Thank you.
Now, this is time for felicitation of the guest of honor, Dr. Arsana Shrestha, Director General, first female Director General of Department of Hydrology and Meteorology. Maybe in the South Asia also, she will be the second or third government of Nepal, and also life member of SAMA Nepal. Now, I'd like to request Dr. Dibya Prakash to introduce our honorable guest. Dibya is the executive supportive member of SAMA. Yeah, Dibya, please.
Thank you so much, sir. So now we are Dr. Archana Shrestha. She is the Director General and first female DG of Nepal's Department of Hydrology and Meteorology, also serving as permanent representative of Nepal with the WMO, a senior climate scientist. She leads national hydromet modernization, high altitude weather forecasting, and early warning system. Her work focuses on glacier monitoring, severe mountain weather risk, and building climate resilience across Himalayan river basins. We are very thankful to you, ma'am.
I hope Dr. Archana is there.
Yeah, she is there.
Switch on
Your
her
voice
video.
is not proper.
Requested to switch on her video also.
Yes, sir. Her video is switched on, but the sound is the some
Voice,
issue,
yes,
technical
sound
issue.
is not proper. Yeah.
Do I stop sharing the
Yeah,
slides, sir? Or to share?
yeah,
Okay.
yeah, sure. I think she's trying to solve the technical issues. Dr. Arsana Shrestha, can you hear us? Hello.
We see her video is on again.
Maybe she's trying to rejoin, right?
Yeah, she is in meeting, but
Oh,
We can see her in the meeting, like her screen is on, but we cannot see her right.
Yeah.
Hello?
Yeah,
Yeah.
now
Oh,
perfect.
yeah, we can hear you now.
Hello?
Yes, it is
Yes,
perfect
now
now.
you are visible. Now you are audible, ma'am. Yeah.
Dr. Archanaji, can you hear us? Hello.
Her audio is connecting now, it shows on the screen.
Okay. Yeah.
Yeah, now. Yeah. Hello, ma'am, can you hear us?
Seems he has not permitted her audio to be connected.
It's
Now,
yeah, there are some technical issues, probably. If there is a delay, perhaps we could have the next guest.
Hello?
Oh yeah, we
Yeah,
can hear.
now okay.
We
Oh,
can
okay.
hear.
There's some. Yeah, so there is some technical glitches. Okay, so
Yeah.
all of you can hear me now, right?
Yes, ma'am.
Right. Perfect.
Yeah.
So, respected President of SAMA, Secretary of SAMA, Chief Guest, Dr. Krishnan, and my colleagues, distinguished panelists, fellow meteorologists, climate scientists, and members of SAMA across South Asia. Namaste and good afternoon. Today, I'm honored to address this session on the occasion of 7th Foundation Day of South Asian Meteorological Association, SAMA, as Director General of Department of Hydrology and Meteorology of Nepal, and also as a proud founding member of SAMA. I extend my sincere gratitude to Sama's leadership for inviting me to deliver this address and also for the gracious felicitation extended to me today. Today's theme on the Foundation Day is Advancing Atmospheric Science for Climate Resilient South Asia. It couldn't be more timely or crucial and also captures the core mission that binds our scientific community together. Since its establishment on August 3rd, 2020, under the motto of sharing knowledge of weather and climate without borders, SAMA has grown into a vibrant non-profit scientific network reaching over 800 members across the Asia. SAMA's operational progress stands as a model for regional collaboration. Specifically, its extensive weekly online lecture series covering topics like atmospheric physics, atmospheric dynamics, satellite meteorology, radar meteorology were very useful and impactful for the meteorological education for thousands of students and early career researchers in this area. Furthermore, SAMA's joint regional collaborations such as monsoon forecasting workshops with SOFAM demonstrate how SAMA translate atmospheric research directly into the disaster risk reduction and food security. And similarly, the research going on in cloudburst is also a good initiative in regional collaboration. The establishment of Young Researchers Curriculum, URS, the National Meteorological Olympiad, the annual SAMA Student Champion Award showcase the SAMA's commitment to nurturing our next generation of scientists. I, as a founding member of of SAMA would like to thank executive committee members and all of you who have worked hard to make this happen and to bring the SAMA in today's state. Nepal, with extreme topography ranging from lowland Terai plains to high Himalayas peaks, faces severe meteorological challenges in this sector. Nepal has also taken a proactive step in regional scientific integration with the launch of SAMA Nepal chapter on January 8, 2025. This milestone has bridged operational experts in the Department of Hydrology and Meteorology with academic researchers at Tribhuvan University's Central Department of Hydrology and Meteorology, and also the Department of Meteorology and other organizations working in this area in Nepal. So as we gather here today, I would also like to highlight the necessity of the scientific mindset and also the power of thinking again. As we gather here today as a scientist, we must remember that advancing atmospheric science is not just about computing faster or collecting data and analyzing those data. It also demands an internal commitment how we think. I'm just recently reading a book called Think Again and the Power of Knowing What You Don't Know. In this book, the author, Adam Grant, reminds us that scientific thinking favors humility over pride, doubt over certainty, curiosity over closure. He defines a thinking concept, a scientific mode. Being a scientific mode means searching for the reasons why we might be wrong, not just the reasons why we must be right. It means recognizing that if knowledge is a power, knowing what we don't know is a wisdom. In rapidly changing climate, intelligence is no longer just the ability to think and learn, it is also the ability to rethink and unlearn. When the atmosphere presents us with shifting baselines, unprecedented weather extremes, updating our models and revising our assumptions is not a defeat, but it is a mark of scientific integrity. And thinking again and knowing what we don't know also encourages us to explore more in this area. So, in conclusion, as we celebrate SAMA's 7th Foundation Day, let us commit to the priorities of our region, strengthening fundamental meteorological research, reinforcing our understanding of the basic atmospheric processes across Asia. Just today's presentation by our keynote speaker, the main presentation also is an example of why we need to explore the fundamental meteorological systems in this area. So most of the time we borrow theories and understanding from mid-latitudes as well as the tropical science, but I think we need to start our research to understand our climate and weather systems in this area. And second is enhancing weather and climate modeling, also including the AI to capture continually rethinking and refining our high resolution models to capture localized weather in the complex mountain terrains. And the third and very important one, converting science to policy. So we need to think from the perspective that ensuring our atmospheric research informs local governance, disaster management, climate adaptation strategies, so that we can have the sustainable development. And fourth, expand student engagement and citizen science, investing in the early career researchers such as those recognized today through a SAMA Student Champion Award, and empowering youth through URS and school outreach. I think we have to do more on this. And finally, the fifth one being a woman in this area. So I think we also need to empower women in the atmospheric science, fostering inclusiveness, diverse leadership across the South Asia scientific institutions. By remaining actively open-minded, questioning our tools, nurturing our joint regional researches, we can build the climate resilient South Asia. And also, I would like to congratulate again to the leadership members, student awardees of SAMA, and I wish the Foundation Day celebration and upcoming panel discussion immense success. Thank you so much. Dhanyabad.
Thank you so much, madam, for your wonderful, insightful talk. Now I would like to call upon Dr. Rohini Bhavar, who is the ECT member of SAMA and, who is also an associate professor at the Savitribai Phule University, Pune, India, in the Department of Atmospheric Sciences, to kindly come over and introduce our next guest of honor, Dr. Amitabh Bandyopadhyay.
Thank you, Dr. Polomi. It's a great pleasure to introduce our guest of honor, Dr. Amitabh Bandyopadhyay, or also known as Dr. Amitwa Bandyopadhyay. He is presently the Director General of NAM S&T Center. He's a very distinguished scientist, accomplished research leader, and respected administrator with more than 40 years of exemplary experience in research, technology development, and scientific management. He holds degrees in chemical and metallurgical engineering from Jadavpur University, the Indian Institute of Science, and IIT Kharagpur, along with postdoctoral experience at Penn State University and the University of Leeds. His outstanding career spans mineral and materials processing, ferrous metallurgy, cleaner technologies, environmental management, and sustainable industrial development. He has contributed more than 150 research publications and presentations. He holds 15 patents and has edited 7 books and number of conference proceedings. He has served in several prestigious leadership positions such as SAIL, National Meteorological Laboratory, CSIR ISTAD, and CSIR Recruitment and Assessment Board. His remarkable contributions have earned him several honors, including the Metallurgist of the Year Award, the Indraneel Award, and the International Green Apple Award. A fellow of the Indian Institute of Metals, he has also received the prestigious Royal Academy of Engineering Visiting Fellowship. Thank you, sir, and I request you to please deliver your address.
A very good afternoon to all of you. Am I audible? Can you hear me clear?
Yes, sir. Yes.
Okay. Air Vice Marshal Professor Ajit Tyagi, the distinguished president of the South Asian Metallurgical Association, Dr. R. Krishnan, former director, Indian Institute of Tropical Meteorology, Pune, and chief guest for today's program, Dr. Archana Shrestha, Director General of the Department of Hydrology and Meteorology, Government of Nepal, and also the guest of honor, my very good friend, Professor Dr. Someshwar Das, Secretary of the South Asian Meteorological Association, esteemed scientists, researchers, academicians, policymakers, ladies and gentlemen. It is a great pleasure to join you on the occasion of the 7th Foundation Day of the South Asian Meteorological Association. I extend my heartfelt congratulations to SAMA for its remarkable contributions to advancing atmospheric sciences and strengthening regional scientific cooperation in the South Asian region. I'm thankful to Professor Tyagi and Dr. Someshwar Das for inviting me for today's program. The theme that has been identified by the leadership, advancing atmospheric science for climate resilient South Asia, is both timely and significant. South Asia is among the regions most vulnerable to climate change, facing increasingly frequent extreme weather events, floods, droughts, heat waves, cyclones, and changing monsoon patterns. El Nino has also added more impacts on all these issues. Addressing these challenges requires robust scientific research, innovative technologies, and above all, strong regional cooperation. We at the Center for Science and Technology of the Non-Aligned and other developing countries which is in short called the NAM Scientist Center, is an intergovernmental organization committed to atmospheric sciences as a critical component for sustainable development and climate resilience. Through the organization of international workshops, training programs, training courses, collaborative research, and capacity building initiative, the center supports the member countries and other stakeholders in strengthening scientific capabilities for climate adaptation, disaster risk mitigation, environmental monitoring, and the other issues related to sustainable development. We also encourage the application of emerging technologies, including AI, remote sensing, big data analytics to enhance weather forecasting and early warning systems. I'm pleased to mention that amongst our recent publications is a monograph published by Springer Nature Singapore, Severe Storms, Anatomy, Early Warning Systems, and Aftermath in a Changing Climate Scenario, which has been edited by Professor Someshwar Das, Secretary of SAMA, along with Dr. Wee Kuo Tao from the NASA Goddard Space Flight Center, Maryland, USA, which makes a valuable contribution to advancing scientific understanding of extreme weather events and climate resilience. This is a book which took nearly 2.5 years to make, started as a just friendly discussion between myself and Dr. Someshwar Das. Ultimately, when the book came out, it has got nearly 750 pages of very, very relevant information and 26 chapters. As I told you that the NAM Center also publishes extensively, and this above book is one of the 105 edited books published by us in different S&T areas that are important and relevant to the developing world. The challenges posed by climate change transcend national boundaries, as you are all aware. Therefore, partnership among scientific institutions, meteorological agencies, policymakers, and regional organizations such as SAMA are essential for generating actionable knowledge and translating science into effective policies and community resilience. Even though SAMA is a young scientific organization, only 7 years old, it is doing a great job in taking scientific knowledge forward in the areas of atmospheric science, preparing next generation of scientists for this important area, and disseminating knowledge on weather-related issues to common people. On this special occasion, I again congratulate SAMA on this successful journey over the past 7 years and wish the association continued success in promoting excellence in atmospheric science for the benefit of South Asia and beyond. I am confident that today's deliberation will inspire new collaborations and innovative solutions towards building a more climate resilient future. As we all realize that atmospheric science is an extremely complex subject. So what I would suggest the youngsters, even though I'm no atmospheric scientist, but always try to think out of the box. Because from that place, the actual solution will emerge. Thank you once again, and I wish you all a very successful celebration today. Thank you.
Thank you, sir. Thank you, Dr. Amitav Bandyopadhyay, Director General of NAM and Science and Technology Center. So it's an amazing inspiration for all the distinguished audience. So now it is time for photo session. May I invite all distinguished guests, SAMA Executive Council members.
Before that, Dr. Mohan, I would like to mention and thank Dr. Bandyopadhyay also for publishing the fact file on heat waves over South Asia jointly with the NAM Scientist Center and SAMA. So thank you very much once again, Dr. Bandyopadhyay, for that. Thank you.
Sorry, I should have mentioned. I forgot that.
Okay. So it is time for photo session, as I mentioned. So everyone, it is my heartiest request to all. Please switch on your video. So let us capture this moment as a symbol of our shared commitment to advancing meteorological science and regional cooperation across South Asia. It will be a good memory for all of us. So please switch on your video.
With your permission, can I just add one sentence? The publication of the Severe Storm book was an extremely complex task. And the way Dr. Das has handled, thank you, Dr. Das. Thank you so much for finally making it happen.
Thank you very much.
Thank you so much.
Thank you very much. Thank you. Thank you.
So please be kind to switch on your video so you can take some screenshot. I would like to request all the student volunteer and executive coordination team member, please take some screenshot. I am also taking.
Yeah, taking.
Dr. Rajan, could you please switch on your video? Still many are missing. As in Mr. Sir, we will miss you if you are not in the video. And Bankota Srinivasan sir, please. Harshavardhan, Satish VS, or Shane Mustafa. And Dr. Nagamindra Dahal, please. Dr. Rahadar sir, could you please? And also Khalid Halim, please. And many others. Pramila, Kamaljit.
Yes,
please.
I'm
Please.
here, dear Kumar Das. How are you?
Okay, fine. So now we are taking a screenshot. So please.
Please be ready, everyone. We are taking the
In front
screen.
of me. لماذا؟ هذا مخور غرتك والكاري ولكي ولا
Okay, be ready. One, two, and final one. So Paulomi, have you taken?
Yes, sir. Yes.
Yeah, I have also
Okay.
taken.
Yeah.
Okay, excellent. Thank you so much for your nice cooperation. Paulomi, over to you.
Thank you, sir. And now I would like to again invite our Honorable Secretary, Professor Someshwar Das, sir, for the brochure release. And
Release.
do we
well,
and take it over, please, sir. Thank you.
May I request the chief guest, Dr. Krishnan, to release the latest Brochure of SAMA formally. Well, let me display it probably on the screen. Share.
All right.
I hope just a second.
I request you to please mute the
Is my screen
Co-host can mute.
Is my screen visible?
Yeah, I did.
Yes, sir. Yes, sir.
Yeah.
Well, this is the latest Brochure of SAMA, and our chief guest, Dr. Krishnan, can officially release this saying whatever you would like to say about this brochure. So,
Yeah.
Dr. Krishnan, please,
Yeah, thank you very much, Dr. Someshwar Das. I'm very happy to release this SAMA brochure, August 2026, and heartiest congratulations to SAMA and all the members of SAMA. Thank you very much.
Congratulations to SAMA.
Thank you. It will be available shortly on the website of SAMA for anybody to download it. Okay, thank you.
Okay, yeah. Book is released. Yeah, thank you.
Thank you. Stop sharing.
Yes.
Yes, sir.
Now I'll share for the panel discussion, and if Dr. Mohandas could again.
Okay, no problem. So with this, our one session is completed. So now next is the very important sessions. That is the panel discussion. A panel discussion on the advancing atmospheric science for climate resilient South Asia. So for this, I would like to request our two moderator, Ms. Chatushka Brahmachandra, Executive Coordination Team Member of SAMA and Senior Meteorologist of Sri Lanka Meteorological Department. And also Dr. Shagata Paira, Associate Professor, BIT Mestra, and Honorable Treasurer of SAMA, as well as the Executive Coordination Team Member of SAMA India as well. And the moderator of the panel discussion is the Dr. Kamaljeet Ray, Scientist G, Ministry of Science and Art, Ministry of Art Science, and live member of SAMA. So, Ms. Satushka, Premachandra, and Dr. Shagataji. So, what to you?
Yeah, thank you, Dr. Mohan. So let's introduce our moderator of the panel discussion, Dr. Kamaljit Ray. She is a senior atmospheric scientist and scientist G and advisor at the Ministry of Earth Science, Government of India, with extensive research in severe weather phenomena, including heat waves, tropical cyclones, cloud bursts, urban floods, even also I noticed lightning. She has spearheaded key national research programs on nowcasting and meteorological risk assessment, driving early warning initiative to protect vulnerable communities. Welcome, ma'am, and also Kamalji, ma'am, I have seen you.
Yeah, actually, my video is not working. You can hear me?
Yeah.
Yeah.
So,
Thanks.
welcome,
Thanks.
ma'am.
Yeah.
Yeah, Mohan, can you go for the next slide? Where Ms. Chatushka, are you there?
Yeah.
Yes, I am there. Yeah. Thank you, Dr. Swagata. It's my privilege to introduce Professor M. Shahjahan Mondal. He is a prominent water resource expert specializing in hydroclimate risk and flood management. His interdisciplinary research focuses on deltaic hydrology, urban flood resilience, and climate adaptive water infrastructure. He regularly advises top national policy framework in Bangladesh, bridging the gap between atmospheric science, hydrological modeling, and water security across the vulnerable coastal and riverine communities. The floor is over to you, Dr. Sagata.
Thank you, Ms. Chatushka. Now I welcome Dr. Pradeep Thaplial. He is a leading satellite meteorology expert, heading key division at ISRO Space Application Center. His work centers on remote sensing, geophysical parameter retrieval, and atmospheric sounding. He has spearheaded critical algorithms for INSAT and OceanSat missions, advancing South Asia satellite-based observation capabilities for tracking extreme weather, ocean dynamics, and shifting atmospheric conditions from space. Welcome, Dr. Thaplial. Yes, Charushka,
Let me introduce the panelists, Dr. T. Narayan Rao. He is a distinguished atmospheric physicist at ISRO National Atmospheric Research Laboratory, specializing in radar meteorology, cloud microphysics, and boundary layer processes. His research unveils the complex physical dynamics behind monsoon variability and severe rainfall. His observational campaigns and radar diagnostics provide virtual baseline data needed to improve regional weather forecasting and numerical prediction models. I would invite Dr. Sagata to introduce Dr. Ifran Tariq.
Thank you, Charushka. I have seen Dr. Irfan Tariq today, though I didn't get any reply. So, sir, are you there? Yeah. So, he is a seasoned climate policy leader with over 3 decades of public service across the Pakistan Meteorological Department and Ministry of Climate Change. A former IPCC focal point, he has shaped national climate adaptation policies and disaster risk reduction frameworks, bringing invaluable strategic foresight on translating atmospheric science into actionable policy and regional climate governance. Welcome, Dr. Tariq, in our platform. And now, Chatushka, you can continue.
Let me introduce Dr. Nabansa Chakraborty, former Deputy Director General at IMD and PNA in Operation and Agrometeorology across South Asia, spearhead of the transformative Gramin Krishi Mosam Seva, and currently advises World Bank projects on agromet services in Bangladesh, Nepal, Bhutan, and Pakistan to enhance farmer decision making. Thank you.
Thank you, Mr. Tuska, and welcome to all the panelists. Now the floor is with Dr. Kamaljit Ray.
Thank you, Dr. Swagat. Thank you, Chatushka. So, Dr. Tyagi, Dr. Das, Dr. Krishnan, Dr. Archana, Dr. Bandyopadhyay, distinguished panelists, esteemed delegates, colleagues, ladies and gentlemen, a very good evening to all of you. I start by congratulating President, Secretary, and other executive members of SAMA on the 7th Foundation Day anniversary today. So, It's my privilege to welcome you all to this panel discussion on advancing atmospheric science for climate resilience, South Asia. I'm so sorry, my video is not working, and I'm just hoping you are able to hear me because I'm not very used to working on laptops. I generally work from office, so at home I'm trying with laptops. I hope it's working. Everybody is able to hear me, I think. Audible, I think. Okay.
Yes, perfect.
Yes, ma'am.
Yeah.
Yes.
Thanks a lot. So as you all know, South Asia is home to nearly 1/4 of the world's population and is among the regions most vulnerable to the impacts of climate variability and climate change. The increasing frequency and intensity of heat waves, cyclones, floods, droughts, glacial hazards, air pollution, changing monsoon patterns, they all remind us that climate resilience is no longer a future aspiration, it is an urgent necessity. These challenges transcend national boundaries. Atmospheric processes do not recognize political boundaries. Therefore, our scientific understanding, technical innovation, and collaborative efforts must also transcend boundaries. Today, we are privileged to have an eminent panel representing National Meteorological Services, space science, atmospheric research, agriculture meteorology, and academia from across South Asia. And their collective expertise reflects the multidisciplinary approach needed to transform atmospheric science into an actionable climate service. India has recently embarked on an ambitious journey through Mission Mausam, a flagship initiative of Ministry of Earth Science aimed at making India a weather-ready and climate-smart nation. It seeks to transform weather and climate services by strengthening the entire value chain from next-generation observing systems, Doppler weather radars to advanced satellite observations, enhanced high-power computing systems, artificial intelligence, impact-based forecasting, last-mile dissemination, etc. However, India is not alone in this endeavor. Across South Asia, countries have made remarkable progress in strengthening meteorological and climate services. Bangladesh has become internationally recognized for its community-centered cyclone and early warning system, significantly reducing disaster-related mortality through improved preparedness and effective communication. Pakistan continues to strengthen its flood forecasting, drought monitoring, and climate adaptation capabilities in response to increasing hydrometeorological extremes. Similarly, Nepal and Bhutan are enhancing mountain meteorology, glacier monitoring, and early warning systems for landslides and glacial lake outburst floods. Sri Lanka and Maldives are investing in coastal resilience, marine meteorology, and climate services to address the growing risk posed by tropical cyclones, storm surges, sea level rise, and changing ocean conditions. So across the region, National Meteorological and Hydrological Services are embracing digital technologies, impact-based forecasting, multi-hazard early warning systems aligned with global vision of early warning for all. So the atmosphere is shared by all of us. So too should be our commitment to advancing science, sharing knowledge, building capacity, and strengthening partnerships for the benefit of our region. With these thoughts, I warmly welcome all our distinguished panelists and look forward to an engaging and forward-looking discussion. As you all know that we are struggling for time and we already crossed our scheduled time limit. So I would request all the panelists to be very brief and crisp in their answers so that we're able to complete this session in a timely manner. So thanks. I would start with Dr. Thapliyal. My first question goes to Dr. Thapliyal from ISRO. The satellite observations are transforming weather and climate monitoring. What emerging satellite technologies will significantly improve forecasting over South Asia? Your views on that, Dr. Thapliyal.
Thank you, Dr. Kamalji. First of all, I would like to thank SAMA for inviting me to participate in this very important this panel discussion. We all know that what is the importance of satellite observations in weather monitoring and prediction is not new, and it is even more important keeping in mind the South Asian countries due to its location in tropics and nearby oceans, which are dominated by convective events and severe weather conditions such as tropical cyclones, lightning, thunderstorm, cloudburst, etc. Now, in changing climate scenario, it is also becoming more important because these extreme events are also becoming more intense. In order to detect the genesis of these severe weather conditions, we need frequent and high spatial temporal resolution observations that is possible only from the satellite observations. Now, we need a rapid scanning capability from advanced imager. That is the first of more important thing we need from a geostationary orbit. And that say every 1 minute or even better. These days, we need even every 30-minute scanning capability from geostationary advanced imagers that can provide very high resolution multispectral imageries over a mesoscale system. For example, to monitor cyclone, to monitor thunderstorm or cloudburst events, you need these type of high spatiotemporal resolution instruments. Another most important instrument will be a lighting imager. And this also we need from geo because we need continuous coverage over a large area. And by making measurement of lighting activities within cloud, and it can provide timely warning and of lightning strike and heavy rainfall over a particular region. So we have currently we have many advanced geostationary imagers in geostationary orbit all over world, and they are providing 1 to 2 kilometer resolution in several infrared bands and in 500-meter in visible bands. Some examples we already know that over American region we have GOES-R series, over European we have MTZ, over our this Japan and Himawari. Japan is having Himawari 8 and 9, and China is having FY4 instruments. Now, in this region, we want to, they take this initiative to provide such observations from geostationary platforms. So we are moving into the insert fourth generation satellite, where we will have advanced imager as well as a hyperspectral sounder and a lighting mapper to provide observations for these extreme weather events. Now, another aspect will be numerical weather prediction, where also we need very high spatial resolution this data. Most important thing is three-dimensional information on atmospheric three-dimensional structure, that is temperature and humidity. This has become possible since during last 2 decades with the launch of Meteosat series of satellite. The METOP series of satellite as well as the NOAA and now JVSS series of satellites that are having hyperspectral sounder combined with the microwave sounder that can provide you all weather sounding capability, which is very, very accurate. And it's very comparable with respect to ground radio instrument, which we are routinely launching at 0 and 12 GMT. So with these two satellites having, they are operating at 9:30 AM PM orbit as well as 1:30 AM PM orbit. So in order to improve our NWP capability, we need to, this increase the number of orbits which will give you frequent coverage from these polar orbitings, this orbit. So we are also planning to have a similar type of instruments in polar orbit, which will complement to these already existing NOAA and METOP series of satellites. Now, one big gap area is actually the wind observations. So far, we are having wind cloud motion vector wherever there are cloud and water vapor motion vector from geostationary satellite. But having a three-dimensional wind, which is very, very important, is very important. So currently, we are going into hyperspectral sounder onboard geostationary satellite. Infrared sounder onboard METOP third generation satellite is one such instrument that is recently launched, and we are looking forward for its potential. The another instrument which we need for wind profile will be a Doppler wind radar. So, but these are very expensive instruments. Not a single country cannot operate many instruments. So different space agencies, different countries are sharing responsibility in launching such instruments so that we can have a very good three-dimensional mapping of wind structure. Now, these are few satellites, but the most important thing is to understand when we want to predict this cloudburst, thunderstorm, or many other severe weather conditions, you need to have observations within cloud, three-dimensional this observation of cloud and inside cloud, how the cloud droplets are forming, what is the rainfall within the cloud. So advanced LIDAR and radar instruments are the new instrument which we are working on to map the three-dimensional structure of these cloud and prediction system. Then if we are talking about the climate, so for climate to make all these observations, because different satellites will have different type of instruments. So for climate monitoring, we need all these instruments to be consistent, consistent with each other. So we are having under CTMS, that is WMO, we have a group called Global Space-Based Intercalibration System, G6, where we want to tie all these instruments with respect to some state-of-art, SI traceable source of instrument, and then we can make these observations available for global community, and we can make climate quality observations as well as generate essential climate variables for climate monitoring. So now in India, we all know that we have already a new space policy where a strong user requirement is needed to develop new satellites. However, we are continuing our efforts in developing, to doing advanced R&D efforts to develop and demonstrate capability of developing new instruments. And that by demonstrating those capability, the user agencies can come forward and demand those type of instruments for their operational applications. So thank you very much.
Thank you. Thank you, Dr. Thapliyal. As you rightly pointed out, the hyperspectral observations, the microwave soundings, these are the technologies which we have to look forward to improve the nowcasting, to improve the disaster monitoring. And surely with these observations which we have, hyperspectral observations and the microwave sounding technologies are going to help us in our future tackling of the extreme weather events, which entire South Asia is going to experience in view of the climate change scenario. Thank you so much. So my next question is Dr. Tariq from Pakistan. So Dr. Tariq, thank you for coming. So as you know, Pakistan has experienced devastating floods and increasing heat extremes. What lessons have been learned in strengthening early warning system and climate services? And which scientific advances have made the greatest difference in improving forecasts during the last decade? Thank you. Yes, Dr. Tariq? Yeah.
So thank you very much. Thank you very much. And let me start by congratulating SAMA for organizing this wonderful event on the 7th Foundation Day. Congratulations to the whole team, to the whole membership. A slight correction under my the designation shown in the picture is former Director General of Pakistan Meteorological Department, whereas I was former Director General Environment and Climate Change. I am as such not a meteorologist, but a user of meteorology data in policy and programs. So just a slight correction, which I just wanted to highlight.
Yeah. Sorry for that mistake. But I think this question, even as a policy maker, you can aptly will be able to say that.
Yeah. So as was discussed during this today's event and by the previous discussion, South Asia is home to a major section of the world population. And it is also a ground where multiple disasters, meteorological disasters are emerging. We see glacial lake outburst floods, droughts, and floods emerging at the same time. The only way we can resolve these issues is through scientific exchange of information on meteorological data. Pakistan has been experiencing all these meteorological disasters, climate-induced disasters, for quite a long time. We have been seeing cyclones and droughts and gulfs happening at the same time. What we have observed is that we have to be very, very clear on our climate policy and our disaster management profile. In Pakistan, we have used this data, this meteorological data, in defining an institutional landscape, which consists of not only the Met Department, but is closely aligned with National Disaster Management Authority and subsequent disaster management authorities at the subnational level. This information is rapidly passed on from one authority to the next level, and appropriate remedial measures are taken. I would just like to highlight an example of GLOF, which is on the northern side of our country. And these GLOFs are happening very, very rapidly because of global warming. Now, with these radars and early warning systems, we are able to actually secure the lives and property of the communities there. It has been a great success. And my last point would be building on the previous discussions. This is, I would consider meteorology as a life-saving science. And as was discussed, the procedures and the equipment, they are extremely expensive. What we need to do is collaborate amongst ourselves, pass on this scientific knowledge to each of us, because this is how we can help our communities and the humanity. Thank you very much.
Thank you, Dr. Tariq. As I understand, that for us in India, the focus dissemination and community preparedness is something we focusing on nowadays. Impact-based forecasting also, and as a policymakers, we are strengthening that area with more observations and more of connectivity to the ground level. Whatever we forecast, it should reach the ground level. And I think Pakistan is also on the same lines, working a lot on community preparedness, as I've read some of your material. And as you assured us also that a regional cooperation, that is something which we have to look forward to, because whatever is going to be there in future because of climate change is not going to see the boundaries, and all the South Asian countries are going to be affected by that. So we need to have a regional community preparedness. Yeah. Thank you so much, Dr. Tariq. So as I understand, Dr. Rao is not there from NAL. So I'll move on to Dr. Mandal. Dr. Mandal, as you know, universities are producing. I'm hoping we are correct in this. You are university. You are you are a university professor, and so I've framed my question accordingly. That universities are producing next generation of atmospheric scientists. How should academia curricula evolve to meet the future challenges? Dr. Mandal, please.
I hope I'm audible.
Yeah, yes.
Okay, great. So, honorable moderator of the discussion, Dr. Ray, respected co-panelists, distinguished guests, participants, ladies and gentlemen, a very good afternoon to you all. It is indeed a pleasure for me to join this founding event of SAMA. I thank the organizer for inviting me to be a panelist of this great event. As honorable moderator said, I'm placed in an academia. So basically, I'm based in an institute. It is called Institute of Water and Plant Management under Bangladesh University of Engineering and Technology. So I am not by training an atmospheric scientist, but I am basically a water resources engineering, but I have some knowledge on atmospheric science. So the question regarding how the curricula should look like for future atmospheric scientists, as you know, we are facing now some kind of climate crisis, I would say. It means that the global threat of average temperature rising beyond 1.5 degrees Celsius. According to a recent report of UNESCO, education in atmospheric science as well as in climate science is an essential response to the current climate crisis. And for that, in the same report, they have given some key competencies, including system thinking, foresight and planning, collaboration and problem solving, ethical and global responsibility, and creativity and innovation. So if we think how our curricula at universities should be, actually these are the 5 elements that we can actually bring into our curriculum if there is any lapse and gaps. As you know, our system has diverse components. Atmosphere is only one of them. Various physical, chemical, biological processes interplay across these systems. So next generation scientists need to understand and integrate these complex system components. They also need to understand the teleconnections with global drivers to our climate system, particularly the Indian monsoon, and the various feedbacks that is there. So, I mean, based on my readings, though I'm not climate scientist, based on my reading, I found that the understanding of these teleconnections and the feedback mechanism is a knowledge gap according to different literature. Before coming here, I was going through the syllabuses of different universities, particularly those who offer atmospheric science or climate science degree program. In Bangladesh, I found that this integration aspect is to some extent missing. For example, if we are offering a course on, say, physics, atmospheric physics, I do not see much information on, say, atmospheric chemistry. So there is I find that there is a gap. When we are offering, say, a course on climate risk management, hardly I find that there is a course on atmospheric science. So this kind of, gap is there. So I think the universities should look into this, curricula part. The next point that I can make is the next generation scientists would adopt, dynamic frameworks that enable more accurate representation of physical processes across a range of spatio-temporal scales. In the keynote presentation, we have seen such a model. For example, there was a zooming in over South Asia where we can, pick in different geographical features. So we need this kind of, variable resolution model more rather than relying on GCM or RCM. I would say that if we can integrate in one particular model, this kind of, dynamic scale, dynamic spatial and temporal scale in the curricula, and if we can teach the students like that, that would be, the next generation, syllabus for that. Another interesting thing that I also feel is that the data-driven methodologies, including machine learning and AI, this was also mentioned in previous deliberations. This can actually advance art system modeling understanding as well as, the model base. Particularly, this kind of hybrid physics data model can improve, pattern recognition, signal extracting, bias correction in atmospheric science. The curricula also needs to, emphasize the computational skills and also publications in scientific journals. And very importantly, I would emphasize a lot on research ethics, particularly when we are using the data, the model reporting in a transparent way is very much important for the wider community and also for scientific integrity. Usually in the curricula, this part is very much missing. I also emphasize on that every discipline of universities should include some kind of atmospheric or climate science in their curricula. University should also embrace a transformative curricula, meaning integrating climate action into curricula. It is not that we only learn, we only do the physical simulation, numerical simulation. We also need to transform it into our own action, as well as actions of our, families, actions of our peers, the wider communities. We should train students as agents of change in building just and sustainable future. So these are the few points that I can mention at this moment regarding the training of future atmospheric scientists and how the university curricula can embrace some of the new development along with the meteorological observation, climatic observation that was mentioned by previous speakers, including satellite, radar, LiDAR-based technologies. I think these are the areas where we can improve. So thank you.
Thank you, Dr. Mandal. As you rightly told that now hydrology, climate science, data science are now all interconnected. And atmospheric science now has a linkage in various sectors. And you see, we have stakeholders in all the fields. Like if you talk about weather, you talk about climate science, we have stakeholders everywhere. So if we have some of the possible themes which can be included in curricula like climate risk, data science, AI, policy interface. So these are some of the things I think each student should learn in order to better understand what is going to happen in next few decades in view of the climate change scenario, because that will be affecting most of the stakeholders and many sectors, whether it's hydrology, water, agriculture. So I think, and you rightly brought out that they are all interconnected and we should have focus on these possible themes. Thank you, Dr. Mandal.
Thank you.
Yeah. So our next panelist, Dr. Nabanshu Chattopadhyay. He has been one of the pioneers of agro-advisory services, which India has today a very successful model, which he was very much instrumental in doing it for us. So my question to Dr. Nabanshu is, Dr. Nabanshu, the farmers are among the most vulnerable to climate variability, we all know. So how is weather-based agro-advisories evolved over the last decades, and what more is needed to make advisories truly climate resilient? Because as you know, you were at the helm of affairs some, I think, maybe 7-8 years back. So do you see improvement, or some of the advisories have become more useful on more climate resilience, or we need to add more to that? Dr. Nabanshu.
Thank you very much. At the outset, thankful to SAMA for giving opportunity to speak in the 7th Foundation Day. Coming to your question, actually, today's the theme is very interesting, and which is related to your question also. That what are the agromet advisories? What is the climate resilience? What maybe you have rightly pointed out in the beginning that the South Asia, because as the South Asia, the climate crisis is increasing very fast, and so you have mentioned that climate extreme, climate variability, and climate change. But the most important part is that agromet advisories which we are giving to the farmers. So most of the user sector in the South Asia is the nature-based livelihood, for their sustenance, particularly the agriculture, livestock, or like that. And I mean, the World Bank, WMO, they are trying to remodel the system in South Asia, Bhutan, Sri Lanka, and others. But as far as the climate resilience is concerned, which is the most important part, is that as a major part of the operational agreement services these days, because it has been anticipated that if we are not taking the action of the climate resilience through our agromet system, by 2030, millions of people will be going to the poverty level. So we need that one. Now, again, I'm coming to your question that, whatever has been done and whatever we are doing, first we have identified, which are the areas, core areas where the climate resilience is very, very important. First is that soil moisture tracking, then crop health mapping, then disaster and drought warning, then yield prediction, pest and disease detection, then precision irrigation, then strategic adoption. And this is possible today, to do this thing, whatever the advances today. We have seen that in the beginning, the lecture on that Dr. Raghavan, that El Nino, because now if you come across to any kind of literate farmers, they have the first question is that what El Nino and what they are supposed to do, like that. So what exactly we are trying these days, we have taken three component in agromet advisory services to utilize the advances of atmospheric science. First is that high resolution climate data, which refers to graded meteorological data, soil and hydrological data set, in satellite and remote sensing inputs. Secondly, that modeling. Modeling means I'm talking about this numerical modeling, particularly to extended range, and because medium range is very, very now accurate now. Now we are adventuring more, on the extended range and seasonal climate focus and how we can relate to this kind for the strategic planning. And as far as that technology is concerned, we are trying that machine learning and also communication and also expert validated adaptation practices. These are the things. So I feel that if these three component, if we can use more onto the agromet, operational agromet services, I think that climate resilience part, in South Asia, which is very, very important now, that can be done. So my last, submission is that a number of projects has been taken already. One, you may be knowing that one very interesting project of World Bank is CARE project, which is operating in Bangladesh, Bhutan, and Nepal, where this climate resilience has been taken as a big, issue. How they can do this kind of in the to reduce the transboundary impacts of climate change and pool resources to meet and common challenges. And also they are supporting that building resilience to climate change by improving the availability of regional climate data, knowledge, analytics, and developing relevant guidelines, tool, and capacities, and promoting climate resilient decision. So one of the atlas, I'm just mentioning to all of you that one of the atlas has been prepared by jointly in South Asia by International Maize and Wheat Improvement Center and Bolog Research Institute, and also that Bangladesh Agriculture Research Council and Nepal Agriculture Research Council and Natural Research Management Center in Sri Lanka. This atlas name is Atlas of Climate Adaptation in South Asian Agriculture. This is prepared to strengthen the climate smart decision making and unlock greater investment in agriculture resilience. I particularly feel that this atlas should be used, all the countries in South Asia to get a sensible kind of resilience kind of thing. My last thing that I'm sure that SAMA will take more initiative involving regional and global partners like SAFOM, CARE, BRC, and NARC, MARC in other developing climate smart investment and policies, ultimately strengthening resilience in South Asian agriculture system, utilizing advances so far made in atmospheric science. So this is the book, we have this WMO has published last year, where a number of climate resilience, issues have been addressed not only in South Asia, throughout the world. I think this book has given a kind of picture in operational advisory service that how this kind of applications can be done through operational agreement service to challenge the climate resilience in future. Thank you very much.
Thank you, Dr. Chattopadhyay. I really agree to that yes, we need to improve the soil moisture observation, estimates. Then also we should bring in more climate smart agriculture techniques into that. And surely your contributions to this book will be very useful for the community to read and get the maximum benefit out of the suggested climate resilience technologies or suggestions given by you. So thank you so much. I think we don't have much time for any further questions. So I would just like to say that today's discussion highlights that advancing atmospheric science is no longer only about improving forecast accuracy. It is about building resilient societies through stronger observations, better models, impactful climate services, and regional scientific cooperation. So the atmosphere connects all of us, and our scientific response to climate challenges must be equally connected. By strengthening partnerships among space agencies, meteorological services, research institutions, and communities, South Asia can become a global leader in climate resilience. So with those words, I would just thank the organizers for giving me this opportunity to moderate this session. And I thank all the panelists for really exceptional contributions through their thoughts to this discussion. Thank you so much.
Thank you.
Thank you. Yeah, Shagata, please. Yeah.
No. You continue.
No, I thought you were not there. So thank you, Dr. Shagataji and Dr. Chatushka, and also obviously respected moderator of the panel discussion and distinguished panel members. It's a vibrant session. It enhances our knowledge and it will be very much effective for the South Asian region as well as the global. Thank you again for your kind contribution for the betterment of the community. Shagata and Chatushka, would you like to add anything?
I have only one. Hello. I have only one query among. Somebody speaking? No. I have only one query among the panelists. If any panelist has any queries to other panelists, the floor cannot be open an infinite time. But if any panelist has any question to other panelists, like Dr. Thablel, do you have any questions? Thablel is not there, maybe. Okay, any other people has one or two, ma'am. Dr. Kamalji Ray, ma'am, can you take one or two questions from?
Yeah, sure. If you give me time, I'll just ask everyone to just in one line, just maybe 1 minute each. If all of you can ponder on this question, that yes, the weather systems do not recognize political boundaries. How can South Asian countries strengthen scientific collaboration while respecting their national priorities? So I would ask from Pakistan, Dr. Tariq, 1 minute each, all of you, if you can just answer that, please. Thank you.
So I think a good starting point would be disaster resilience, and we see disasters amongst all our countries. This is a region where we can collaborate and save lives of thousands of communities. Not just lives, we can save whatever the communities have in properties and etc. So I think investing in disaster risk reduction and sharing that knowledge could be a good starting point. Thank you.
Capacity building, and I think data sharing is most important. That's most important because that kind of really strengthens our model. The modeling community will be very thankful if we could have those cross-boundary datas the local data, which is very useful for the NWP models. Thank you, Dr. Tariq. Dr. Mandal?
I think if we invest in capacity development, this will pay off. So one way to invest in capacity development, what SAMA is already doing.
Yeah.
Another option could be, to introduce internship. For example, some Bangladeshi student goes to India or Pakistan, stay there for a short period of time, see the developments that is happening there, and in this way they build a network and continue to develop their capacity. So internship can be joint research internship. This can be one option to develop the capacity of the region. Apart from what you said already, data sharing, particularly, people like us who are in the downstream, we always feel there is a need for data.
Yeah,
so
true.
thank you. Yeah.
Thank you, Dr. Mandal. Dr. Thapliyal, you would like to say, because your satellite is seeing every country, and it is a data which every country can take from satellite. So there, I think we don't have much boundaries. And that is, the satellite data is one thing which is really connecting people across regions. Now, if we don't have the data, the land data, we are able to get it from satellite. So do you have some suggestions, or do you have your expert ideas on that?
Yes, actually, the suggestions are that we should the capacity building in the field of satellite meteorology. So far, we have been our atmospheric scientists across Asian countries. They have been using much of ground observations. Satellite observations have been given little less importance. And it is time that, because our region being dominated by convective events and many other extreme weather events. So it is time that we build capacity in the field of satellite meteorology in our Space Application Center, Ahmedabad, within ISRO. We have a program under United Nations sponsored Center for Space Science and Technology Education in Asia Pacific countries, where we impart 1 year training to this meteorologist or professors of most of the countries. They come here, they learn satellite meteorology, because our group at Ahmedabad is specialized. We have a specialization in this field, satellite meteorology. So they can come here and work here for 9-month course. We give 3 months practical training, and after that also, when they go back to their country, we support them in their further research, and maybe if they want to do MTech or PhD, there also we support them. So in the past many years, many participants from Nepal, Bangladesh, Sri Lanka, Myanmar, and Indonesia, and many other countries, they have come here and they have worked here in this within this course. So SAMA should popularize this course. I would say I will share that brochure. This next course will start next year. So we should have a greater participation from South Asian countries in this course. And to advise to atmospheric scientists, please try to think of gap areas where you have a gap of observations, and what type of observations will improve these forecasting. Once this requirement is there from atmospheric scientists or forecasters regarding certain observations, we can definitely work in that direction to build those instruments. And then only, because once we launch the satellite, it is not for India or for any neighboring countries. It is a global satellite. All nations under WMO are eligible to get this data. We have our own this MOSDAQ data website from all our Indian satellites, INSAT, OceanSat, or any satellite data is freely available from MOSDAQ web portal of ISRO. So those data also can be made available to other countries. They can log in, make user ID, and utilize that data. Any help, we are always ready to help any of the participant, any country, in utilizing that data, and even imparting our knowledge to them. Thank you.
Thank you, Dr. Thapliyal. Dr. Nabanshu, recently you had organized some 3-4 months lecture series involving participants from all the countries. So what was your experience? Do you think this kind of capacity building is really is really the need of the day, that whatever we all are excelling in each country and we share it and we strengthen each other. Dr. Nabanshu.
Yeah, actually, no thing is that whatever you have mentioned, that 54 persons in South Asia, they have participated 4 months training, and we have given a, around 40 lectures or like that. Okay, a kind of awareness on the operational aspect of agriculture meteorology is there. So my submission is here that as this is a SAMA's platform, as far as the users community is concerned, I said in my earlier deliberation that that SAMA, SAFOM, and other regional partners, they should sit together, identify the gaps, identify different gaps in that all the three component means data, then modeling, and then is that your technology. So what we have a plan, we can discuss with you maybe in detail, that we are going to based on the successful performance of the training in South Asia involving 8 countries. We have a plan to organize individual subjects, physical training. So maybe in the month of November, December, we may organize a kind of training where climate resilience will be there, where more of interactive kind of things will be there. We'll be asking the participants what are the kind of technology they are having, how this can be shared from other countries, what are the gaps in the regional data gap, or maybe the communication like that. So in-depth kind of capacity building training we will be proposing, because what I feel that though in operational agriculture meteorology we have done a lot, but climate resilience is the most important topic. This thing, I don't know, Rathore Sahib is here. I don't know whether he will be able to speak. He can also add to some of the things if he is able to speak.
Dr. Rathore, Dr. Mohanty, we have many great stalwarts in the session today. And only, I'm not the person who knows the time is available or not. If the organizers, we can hear some few words from both of them.
I think Mohanty sir left and Rathore sir not currently in front of.
Okay.
Yeah.
Okay.
I think we can proceed for the next session. That means.
Okay. Thank you. Thank you so much. We can now just we'll reflect on some 2 to 3 fundamental questions after this discussion. Is that how can these atmospheric sciences advances translate into a more resilient communities? How can regional scientific collaboration strengthen forecasting and early warning across South Asia? And how can we ensure that every scientific breakthrough ultimately benefits the farmer, the fisherman, the city planner, disaster manager, and every citizen whose life depends on reliable weather and climate information? With these words, I would thank the organizers and I would thank all the panelists for their brilliant viewpoints and this discussion. Thank you. Thank you, Dr. Sagat. I will just sign out now. Yeah.
Okay. Yeah. Okay. Thank you. Thank you so much, Dr. Kamal Madam, and especially also Dr. Shagata ji to make the session in a very vibrant and interactive again. So it's really helpful to all. So we also miss the Mohanty sir and also Rathore sir. Rathore sir may be a little busy. So now this is the almost end of the session, but one important segment is still pending and another significant one. So we now come to the announcement of the SAMA Student Championship Award 2026, recognizing outstanding student leadership and contribution to the South Asian meteorological community. May I respectfully invite Dr. Polomi Chakraborty, who behind the scene did a lot to announce for preparing the things. To now, time to announce the recipient of the Summer Student Championship Award. Polomi, please.
Thank you so much, sir. And right now, as the esteemed panelists were talking about how important it is for us to work together to achieve a goal towards like a better climate resilient future. We could not have done this unless we have like with us students and the next generation who are so much important to achieve our any of the goals that we want to achieve. So in the past year, I'm so extremely happy and proud to announce four of our student coordinators across the nations have been chosen as the student champions 2026. So out of six entries, four were eligible, and we had certain criterias that our group of executive council members and SAMA team have noted over the years. And these four students that you see here right now, they have excelled in all of that. And the number one is Fatima Tos Zohra. I hope I'm pronouncing your name correctly. She's from University of Dhaka, Bangladesh, and she has extensively helped Dr. Mohandas to conduct the World Meteorological Organization's the day, WMO day, and she has also helped in all the online activities that SAMA does over the year. So congratulations, Fatima. And then next is our second rank that we the panelists have chosen is Devashish Prakash Singh. He's a student in the Indian Institute of Technology, Hyderabad, India, and he has been working tirelessly with us to host this Foundation Day program. And previously, he has worked for the newsletter and getting outreach done and so many more. So congratulations, Devashish. I'm not sure if he's present here, but great job. Then comes Ashwini Vijay Zadav from, right now he's working with Indian Institute of Tropical Meteorology in Pune. Earlier, he was associated with Savitri Bhai Phule, Pune University, and he helped Dr. Rohini Bhava to conduct the SAMA SPPU atmospheric dynamics lecture series in person, and he was instrumental in holding it all together. So congratulations, Ashwin. I'm not sure if you're here, but you did a great job. And now I would like to also acknowledge Kazi Tanha Ahmed Liva from Bangladesh, and she has been helping with the outreach, with uh, making our message known to the students and so many other places, and she's from the Bangladesh Maritime University. So earlier, as Dr. Archana was talking about how we need more women in our field of meteorology and atmospheric sciences, so this here is an example of, like, men and women both working together for a common goal. So we are so proud of you all, and congratulations, and we hope for you to continue working with us in the future. Thank you so much.
Thank you so
Now,
much. Ma'am. Thank you so much. Ma'am.
thank you, everyone. I would like to stop sharing now, and Dr. Mohan, if you could take over.
Polomi, can we hear as 30 seconds from both of them or both of four if they are available?
Definitely. Any of the participants who have won, if you could come on camera and just say a few words, we would be really honored to have you speak something. I see Fatima is here. I see Kazi is also here.
I see Ashwini as well.
Ashwin also.
Yeah,
Very good. That's good. That's good.
yeah.
Ashwin is also
Respected
here.
all, yeah. I'm deeply honored and grateful to receive the Sama Student Champion Award. And I really thank Sama for recognizing my contributions and providing students like me the opportunity to learn and collaborate. So I would also like, yeah, sorry.
Thank you. Congratulations.
Yeah. So I would also like to express my heartfelt thanks to my mentor and my guide, Dr. Rohini Bhavar. Because of her, I get a chance and I have able to contribute to this association. and the activity we carried out in Savitribai Phule University and in collaboration with SAMA. And yeah, this award is not only recognition of my past efforts, but also a motivation to contribute more actively in SAMA activities and all. Yeah. Thank you so much.
Good. Thank
Fatima,
you.
you're muted. Fatima, please.
Thank you so
Thank you.
much, everyone, to to selection committee and management for giving me worthy of this honor. While my name might be on this award, victory belongs to the entire environment. None of this would have been possible without the unwavering guidance of our dedicated teachers and constant encouragement of our mentors and the incredible support of my teams. Uh, Especially, I would like to name Shihab Rahman, who helped me throughout the program and other activities. Thank you so much. I'm truly grateful. Thank you.
Thank you, Fatima Johra. And Liva and Devashish, are you there? So,
Sir, Assalamu alaikum. I am Kaji Tanha Ahmed Liva. I am studying at Bangladesh Maritime University, Department of Oceanography and Hydrography. I am also a student member of SAMA from Bangladesh. Thank you so much for this SAMA Championship Award, and I am really happy and proud today. This award is not only for mine. Thank you for your support and love. I will try my best to do even better in the future. Thank you again.
thank you so much. Thank you. So, I think Devashish maybe some not joined or something. Okay. So, it's a great opportunity. We would like to get much more contribution from all of you and also engage more students in future. So, Polomi, can we go for next session? Next part?
Yes.
Almost end. Yeah, please.
Sure.
So, please request next.
So now I would like to request Dr. Samarendra Karmakar from Bangladesh to kindly come on online and speak a few words as concluding remarks for this session. Over to you, sir.
Thank you very much. Thank you.
Thank you.
Distinguished guest, respected colleagues, esteemed members of the South Asian Meteorological Association, ladies and gentlemen. As we come to the close of this memorable celebration of SAMA's 7th Foundation Day, I would like to express my heartfelt gratitude to everyone who has contributed to making this event a success. Today, we have reflected on the remarkable journey of SAMA over the past 7 years, a journey marked by dedication, scientific collaboration, professional excellence, and a shared commitment to advancing meteorological and climate sciences across South Asia. This milestone reminds us not only of how far we have come, but also of the opportunities and responsibilities that lie ahead. These challenges posed by climate change, extreme weather events, and increasing societal demands of accurate weather and climate services require stronger regional cooperation than ever before. By working together, sharing knowledge, embracing innovation, and supporting the next generation of scientists and professionals, we can build a more resilient and weather-ready South Asia. I extend my sincere appreciation to our distinguished speakers, organizers, partners, panel discussants, and every participant whose presence and contributions have enriched today's celebration. Your enthusiasm and commitment to continue strengthen the spirit and vision of SAMA. As we conclude this event, let us carry forward the momentum of today's discussions and reaffirm our commitment to scientific excellence, regional collaboration, and service to society. Once again, congratulations to the South Asian Meteorological Association on its 7th Foundation Day. May SAMA continue to grow, inspire, and lead in promoting meteorological science and cooperation across our region. Thank you all for your participations. I wish continued success and look forward to meeting you again at future SAMA events. Thank you very much. Long live SAMA.
Thank you. Thank you so much, sir. Thank you again, Dr. Shamarendra Karmakar.
By the way, Dr.
Vice-
Karmakar is
Sir.
also the
Vice President.
Vice President of SAMA for the current term. Dr. Samita Karmakar is the first Vice President, and Dr. Mandira Shrestha, who is absent today because he is in USA presently. They are the two Vice President of SAMA at present. So thank you, Dr. Karmakar, for your
Thank you,
nice
Dr.
concluding
Dash.
remarks. Thank you, thank you.
But I did not see Mandira.
She
She
is
is
in
not here
USA.
today.
She is in USA, so time zone difference is there.
Uh-huh.
Time difference problem between USA and India.
And also, I don't see my friend Madanji.
He is
No,
there.
Shrestha sir is there. Shrestha sir is there. Sir.
Yes, now I can see him. Yes.
Shrestha sir, please say a few words. Unmute, please.
Hello,
Yeah, the former Vice
Dr.
President of
Madan.
SAMA.
Yeah.
Thank you.
I
Thank
think I don't want to take more time, because I'm really happy, and I congratulate everybody, for the members, for the achievement, not only in the South Asian region but across the globe. So I think we should feel very proud of this, and definitely I think these are some of the works of Dr. Tyagi and Dr. Someshwar. So I think today I also feel very good to hear, the Krishnan, giving wonderful presentations. And I'm also impressed from Dr. Kamaljit Ray. I think it's a great moderation, I can see, but we just wish that we will have more time to listen to our speakers and also the insights from Dr. Kamaljit Ray. So I think I don't want to take more time. I congratulate everybody, including myself, and I feel very proud to be the member of SAMA. And let us hope that we march forward, taking SAMA to greater heights. Thank you very much.
Thank you so much, sir.
Thank you, sir. Thank you.
Thank you. So now it is time for vote of thanks. I would like to request Dr. Madan Sikdel, Executive Coordination Team Member and Associate Professor of Central Department of Hydrology and Meteorology, Tribhuvan University, Kathmandu, Nepal. Dr. Madanji, please.
Thank you, Dr. Mohan. On behalf of SAMA, it is my privilege to extend our heartfelt gratitude to everyone who has contributed to make 7th Foundation Day celebration a grand success. First and foremost, I would like to thank our chief guest, Dr. R. Krishnan, former DG of IITM. Your enlightening education on current challenges on meteorological issues has been incredibly insightful. A special thanks to guest of honor, Dr. Archana Shrestha, DG, DHM Nepal. Your keynote address provided valuable perspectives. Similarly, special thanks to guest of honor, Dr. Amitabh Bandyopadhyay, DG, NAM SNT Center. Your keynote address was truly compelling. We are deeply grateful to our distinguished panelists for panel discussions on the recent issue. Your expertise have enriched our understanding of collaborative efforts. We like to thank Professor Dr. Yam Sahajan Mondal, Dr. Pradeep Thapiyal, Dr. Mohammad Irfan Tariq, Dr. Navengshu Chattopadhyay. Special thanks to Dr. Kamaljit Ray for moderating the panel discussion. I would like to express appreciation to the President of SAMA, Dr. Ajit Tyagi, and Secretary of SAMA, Dr. Someshwar Das, for the comprehensive overview of the SAMA activities. A heartfelt thanks to program moderator, Dr. Pulomi Chakravarti and Dr. Mohan Kumar Das. Thanks to Dr. Swagata, Mrs. Chatuska Premachandra, Dr. Kiao Thano, Dr. Rohini Power, Dr. Millie Ghosh for introducing panelists, chief guest, guest of honor. Congratulations to the recipient of the SAMA student champions of 2025. Your exceptional contribution have been recognized today. Our gratitude extends to all the Executive Council team members of SAMA. Last but not least, a big thank you to our organizing team for their hard work and dedications. To all our distinguished guests and speakers and participants, thank you for taking your time to join us today for your valuable contributions. Wishing you a pleasant evening. Thank you all.
I would like to additionally thank Dr. Mohan Kumar Das. He is attending this program from Japan, by the way. Many of you may not be knowing, and it is quite late there, I think, maybe about 9 o'clock or 10 o'clock in the night.
9:30, sir. 9:23.
9:30. 9:33 at night. So thank you so much for taking your valuable time from your Japan trip and attending the SAMA program, which you considered it so important. Thank you very much. By the way, everybody knows he is the Joint Secretary of SAMA since the beginning. Thank you, Dr. Mohan.
Thank you, sir.
Thank you.
Sir.
Thank you, Dr. Swagata
Thank you
Paira,
everyone.
Dr. Kumar
Bye-bye.
Das, and all dignitaries. We had a wonderful time. I learned so many things, sir. Thank you so much.
Thank you so much, sir. Thank you.
Thank you all. Thank you.
Thank you all.
Thank you. Thank you all.
Thank you, sir. Thank you, sir.
Thank you. Namaskar.